This video is related to all the different transformation videos I've done before, but this time we're going to look at describing transformations instead of actually completing them. So first, how do we spot each transformation? Well, everybody has their own way of doing it. I do this sort of flow diagram in my head. So first up, I asked myself, right, are the two shapes on the grid different sizes? If they are, then it is an enlargement. If they're not, then I go on to the next question, which is, are the shapes identical but in different positions? Have they just been moved on the page? If that's true, then it's a translation. If not, I go down to this last little section. So lastly, I asked, has the shape just been flipped over? If it is, then it's a reflection. If not, then it's a rotation. Now, another way of remembering this one as well is reflection. Is the question worth 2 marks? If the question is worth 2 marks, then it's a reflection. If it is worth 3 marks, it's a rotation. And we'll go through in a moment why it is that reflections are only worth 2 marks, whereas rotations are worth 3. Okay, so starting off here, I want to describe fully the single transformation that maps triangle A to triangle B. So I'm asking myself first, are the shapes different sizes? And clearly, yes. So this is an enlargement here. Okay, so how do we describe an enlargement? Well, an enlargement requires a scale factor. So to find this scale factor, we just need to compare two lengths. Now here I'm going to compare this length down the bottom here, which hopefully you can spot is 3. I'm going to compare it with the base of B. Now the base of B is 6. So hopefully you can see this is doubled in size. So it has a scale factor of 2. Now the next thing I need to do an enlargement is to identify where the center of enlargement is. Now the way I would do this is to get a ruler and to join up all corresponding corners. Now what do I mean by this? Well, if I take this bottom left corner of B and join it up with a straight line with the bottom corner of A, then I take the top corner of B and I join it with the top corner of A. And in fact, if I did it with the third corner as well and join that with the corresponding corner of A, you'll see that all of these lines go through the same point here. And this point is at 410. And this 410 is the center of the enlargement. So to answer this question, I need to say it is an enlargement of scale factor 2 with center 410. Now, enlargement questions are worth 3 marks, and the first mark is for stating it's an enlargement, second is for getting the correct scale factor, and the third is for getting the center. Okay, so here's a different transformation. I'm going to ask myself the same starting questions. Are the shapes different sizes? In this case, no, they're not. Are the shapes identical but in different positions? In this case, it is a yes. So this must mean it is a translation, as the shapes haven't been tilted, they haven't been twisted. Okay, they're just the same shape, only in a different position. Now, translations are described by vectors, and if you can't remember vectors, then I suggest you have a little look at the translation video. But to find this vector out, we're just going to take any corner from A. So A, I'm just going to take this top corner here. So I'm going to start with my across movement. Now this A has been moved across 1, 2, 3, 4, 5, 6 left, and it's been moved up 1, 2, 3. So my vector will be 6 to the left and 3 up. So to describe this transformation, firstly I need to say it is a translation of vector. Now remember, vectors have squared brackets. So it was 6 to the left. So remember, left, I need to make it -6. And then 3 up. So 3 up. So it's a translation of vector -6, 3. So translation questions are usually only worth 2 marks. 1 for stating it's a translation and 1 for getting the correct vector. Okay, so this next question again, I'll start it the same as I have before. Are the shapes different sizes? In this case, no, they're not. Are the shapes identical but in different positions? Again, no, they're not. Is the shape just flipped over on itself? And again, no, it's not. So that means it must be a rotation. So how do we describe a rotation? Well, firstly, we need to have an angle in which it's rotated by. So here you can use tracing paper, or you can spot that this shape has been rotated 180 degrees. Now remember, you do have to state whether it's clockwise or anti-clockwise, but in the case of 180 degrees, it doesn't matter either way. So we can just state it's been rotated 180 degrees. So after you've found the angle of rotation, the next thing you need to do is find the center of rotation. Now, unfortunately, there's no easy way of doing this. It is just a case of trying different points, spinning the shape around and seeing if it fits. So to begin with, I'm going to try the origin, okay, this point 0, 0. So I've drawn my shape onto my tracing paper. I'm putting my pencil down at the origin, and I'm going to now spin my tracing paper around that to see whether that shape matches on or not. Now, as you can see, as I get round to 180, it doesn't quite match up. So what I'm going to do now is I'm just going to mark on my tracing paper with a cross this point, the origin, to show that I've tried this and it didn't work. Okay, so next what I'm going to do is use my pencil and try the point above it at 0, 1. So again, I'm just going to spin my paper around 180 degrees. And here you notice that the shape does actually fit onto it. So that means where my pencil is actually the center of rotation. So now I can write down what the transformation is. So first off, I need to say it is a rotation. I'm going to say what angle it was of 180 degrees. Remember, if it was 90 degrees or 270 to write down clockwise or anti-clockwise. And now I need to also put in center, and the center, where is my pencil? Well, my pencil is at the coordinates 0, 1. So again, like the enlargement, you got 1 mark for saying it's a rotation, 1 mark for the angle, and you get another mark for the center. So this is why rotation questions are 3 marks and reflection questions, you'll see, will just be 2. So again, another way of spotting rotations and reflections. Okay, so here's another transformation, and again, I'm going to start by asking my questions. So are the shapes different sizes? No. Are the shapes identical but in different positions? No. Is the shape flipped over? Yes, it is, as you probably guessed. So this is an example of a reflection. So how do we describe a reflection? Well, what we need is a mirror line, okay? So this is the line that is halfway between the two shapes. So just like when we were doing examples of things like the median, we're going to find this mirror line in exactly the same way. We're going to count 1 square in from A and 1 square in from B. 1 square in from A again and another 1 square in from B. And we're going to keep going, and you see that we get a line in the middle here. So drawing this with a straight line, now, unfortunately, it's not good enough to just draw this line in. We've also got to name it. So here, this is a line that goes through the x-axis at 3. So we call this line x equals 3. Any vertical line will be exactly the same. It will be x equals, and then the number it crosses the x-axis. Horizontal lines are slightly different. So here I have an example of a horizontal line. Now this is going through the y-axis at the number -4. So here a horizontal line I will call y equals -4. Right, so now I'm ready to describe the transformation. It is a reflection in the line x equals 3. So here you get 1 mark for saying it's a reflection and 1 mark for saying what the mirror line is. So as you can see, reflections are worth 2 marks, and again, like I said earlier, rotations are worth 3. So we've gone through an example of each transformation. Now I've just got one more on the board here because this is a special case that loads of people get wrong all the time. Now again, I'm going to run through the questions that I usually go through. Is it bigger? No, it's not, so it's not enlargement. Is it just the same shape? No, it's not. It's not a translation. Has it been flipped? Now this actually looks more like a rotation than a reflection, but unfortunately that's where people go wrong. This is actually a reflection. It's been flipped in a very special line. And this special line is a diagonal line going through the origin, like this. Now, the name we give this line is the line y equals x. So just watch out for sometimes they give you this reflection in the line y equals x, which looks like a rotation. But again, you can usually spot this because reflection questions are only worth 2 marks. So if you see a question that looks like a rotation, but it's only 2 marks, remember that must be a reflection. So to describe this, we would say it is a reflection for 1 mark in the line y equals x. Okay, so hopefully that's helped you to describe transformations. I recommend that you have a little look at all the other videos on how to perform the transformations as well. Okay, and then practice all the different exam questions you can on these. Now, they usually like to give you one transformation to do in either the non-calculator or calculator, and they usually like to give you a describing question in the other paper. Sometimes I've even seen 3 transformation questions in a set of 2 papers. Okay, practice this and good luck.